All right, so that's a review of yesterday, adding, subtracting matrices, and then multiplying by a scalar, which acts exactly like the distributive property. The next thing we're going to work on then is the goal for today, which is multiplying matrices. Somebody in 6th period yesterday asked me the most wonderful question. They said, it's going to get harder than this, isn't it? Why did they say that? Because yesterday was way too easy, wasn't it? I'm going to start by giving you the dimensions of a small matrix. So let's start with a matrix that is a 5 by -1 and a 3. 5, -1, 3. I'm going to call this matrix A. Tell me the dimensions of that matrix. I heard it. 1 by 3. Good. Perfect. Now, when you multiply matrices, then there has to be a certain set of rules, just like yesterday. When you add them, the number of rows have to match, and the number of columns have to match. Well, in order to multiply, the columns of matrix B have to match the rows of matrix B. So A, whatever its amount of column is, it has to match B's amount of rows. And the coolest thing happens, those drop out, 3 and 3, and the answer matrix is always the rows in matrix A and the columns in matrix B. So I'm going to have a 1 by 2 in my final answer. So it's going to have 1 row and it's going to have 2 columns. Going to say that again. When you multiply 2 matrices, you have to have the 3 in this case for matrix A. The columns of matrix A have to match the rows of matrix B. So I know that in order to do this, since I'm teaching this lesson, I know that I have to have 3 rows, and I could make this whatever I wanted. But these 2 inside numbers match. That's how you know you can multiply. And then the answer matrix is always the 2 numbers on the outside, so I know in the final answer that guy's a 1 by 2. So to make it easier, I'm just going to make it a 1, 2, 3, 4, 5, 6, because that's really quick and easy to write down. So 3 rows, 2 columns, with it being 1, 2 across, 3, 4 across, and 5, 6 across. At this point, if you are a person who tries to do more than one thing at once, multitask, stop, because this right here, it just takes concentration, but it's not hard, but it just takes concentration. So I'm going to use different colors, and I'm going to say that row 1 must first be multiplied by column 1. Okay, so they're both red. Now here's the thing, that's a big long bunch of multiplication that's going to end up only being 1 number. So when I make my 1 by 2 that I'm going to actually work in, I make it just a little bit larger because I'm going to have like a math problem in here to work. If you watch my fingers, what I do is I take element 1 and multiply by element 1. What is 5 times 1? And that's not hard, but you have to do the right position. So 5 times 1 is 5. You're going to add it to the solution of the middle one. The middle piece of data, -1, is times 3. What does that give us? Good, -3. Then we're going to add that answer to the last element in the matrix and the last element in this column. 3 times 5 is what? So I have this little math problem to work, and the answer goes here. So 5 minus 3 is 2, plus 15 is 17. So I now have my first column in my answer matrix. Now the next thing I'm going to do is I'm going to go back to row 1, and I'm going to multiply it by column 2. So that's why I use different colors. First I do row 1 by column 1, then I have to go back to row 1 and do it by column 2. Hence the green is the second one. 5 times 2 is 10, plus negative 1 times 4 is negative 4, plus 3 times 6 is 18. So 28 minus 4 gives me 24, and that is my answer matrix to this 1 by 3 times this 3 by 2. Again, I do not think it's hard, but if you're a multitasker and you try to do a whole bunch of things at once, when you do these problems, you really have to concentrate. Make sure you've used row 1 with all the columns. Now, what if there were a row 2? Can you conjecture what you would do next if there was a row 2? What do you mean by same thing? Be more detailed. Right. So if you had a row 2, you'd have to go back and take row 2 times what? Column 1, get an answer, a single guy. Then row 2 by column 2, you'd get another single guy. So I want to do one, yes?
And if there was 2 rows, the answers you would get from the second row would be on the bottom.
Because, let's talk about that for a second. This guy would be a what? 2 by 3, and this guy would be a 3 by 2. So then this guy would come down as a 2 by 2, if there was a second row. Good. That's a good question. All right, anybody else a question? All right, what if I do a 3 by 3 times a 3 by 1. Let's do this. Need a kind of big space because we're going to do a 3 by 3. Negative 2, 1, 2, 3, 2, 4, 0, negative 2, 4. That is a 3 by 3. We're going to multiply it by 1x3. And our goal is for it to equal, we don't know yet. All right, first, Britta, tell me the dimensions of matrix 1.
3 by 3.
Perfect. Matrix 2, how about you, Rob? Close. Right, rows, then a column, 3 by 1. What's my answer matrix? Good, 3 by 1. So I'm going to take row 1. What am I going to multiply it by, Savannah? The column. So row 1 times the only column, and she called it the other one, and that's right, there's only one other column in the other matrix. So to go element by element, you say negative 2 times 1, negative 2. 1 times x is x. 2 times 3 is 6. So that's our first one that we'll have to simplify in just a moment. Row 2, what am I going to multiply it by, Dylan? The one column that we have over here. Good. So 3 times 1 is 3. 2 times x is 2x. 4 times 3 is 12. Last but not least, we have a row left. So Lakin, what am I going to multiply this row by? The one column that we have. So we have 0 times 1 is 0, plus negative 2 times x is negative 2x, and 4 times 3 is 12. Then I have these small little math problems to work. X plus 4 goes in position 1. Position 2 is 2x plus 15. And position 3 is negative 2x plus 12. To get your final answer, what would you have to know about this problem? What x is. Otherwise, you're done right here. That's your answer matrix. You've multiplied the 2. You're set up and ready to go on. Let's find the product of one more before we leave this. will you give me the dimensions of this, Rachel? Oopsie.
2 by 1.
Perfect, 2 by 1. Riley G, will you give me the dimensions?
1 by 2.
Perfect, 1 by 2. Wes, will you give me the size of the answer matrix? First, does this and this match? Okay, those disappear, and what's left? When you find the dimensions in the matrix, the two inside things match, and once you check to see if they're a match, they disappear from your imagination. What is left if you don't have a 1 by 1 to come together and be the dimensions? What you have left is a 2 by 2. These would be gone, okay? And then what's left on the rows of this is 2. What's left on the columns of this guy? 2. And you just bring them down. Let's do a couple of these because I guess everybody's not with me on that. What if I gave you a 3 by 2 times the dimensions of a 2 by 7? What's your answer matrix, Hunter?
3 by 7.
Good. What if I gave you a 1 by 3 and a 4 by 4? What's my answer matrix, Kariah?
1 by 4.
If the inside things matched, would she be right? Yes, but Kariah, as soon as you see that 3 and 4 don't match, you remember last night a couple of them that didn't work? Why would this guy not work? Because 3 and 4 don't match. Now, if that was a 3 and that was a 3, your answer would have been perfect. It would have been a 1 by 4. How about if I gave you a 1 by 1 and a 1 by 3? What will my answer matrix be? Erica? 1 by 3. So now, if I ask this question again, it's a 2 by 1 and a 1 by 2. Britta, what's my answer matrix?
2 by 2.
Perfect. Row 1 times column 1. What does that give me? Feels funny, doesn't it? Then row 1 by column 2. What does that give me? 12. Then, am I done with this row and the 2 columns I have? Okay. Now we have to do row 2 by column 1. What is that? -2. And what do we have last? Good. Row 2 times column 2 is -6. So my final answer matrix is 4, 12, -2, -6. Why was that different than any of the ones we've done so far? Right, and before we had small little problems we had to sum together. So that one, it acts the same, but it just looks slightly different. Anybody want to ask anything about that one? The only way to get used to these is to jump in and start working problems because they are just different. They are not hard. So we will move on to the assignment. If you do not have your book, I have some extra books, and we can also take pictures with our phone and then use that as the page. We're going to do number 3 through 8, number 10 through 18 even, and number 37. 3 through 8, 10 through 18 even, number 37. This is lesson 3.6.